Hi everyone, in Algebra 3 today we're going to be going over the new material on lesson 75 as well as some of the problems from this lesson. So we're going to start with learning about combinations in lesson 75. So combinations, the number of permutations of 10 objects taken 4 at a time is the number of different ordered sets of 4 items that can be selected from a set of 10 items. So you remember you saw 10p4 and we had a formula for that. A combination is a selection of items in which order is not considered. So that one, before with permutations, you were considering order. So it's put in a line or in a circle. We're not going to be dealing with that. We're just going to be choosing groups at a time. So basically, all that to say, the new format is going to be n chosen so many at a time. And there's a general expression for the number of combinations of n things taken r at a time as a general expression for the number of permutations of n things taken r at a time divided by r factorial to remove the effect of order. So this right here, the r factorial, is removing the effect of order. But this is the formula that you have to have written down. So the middle section you don't need, but we have n choose r, n items chosen r at a time. And this is the equation that you are going to plug that into. So because this is a new concept, we are going to go through some of the examples. I'm going to go over this one. It says, in how many ways can a committee of 5 students be selected from a group of 12 students? So that means for 75.1, I have 12 students chosen 5 at a time. And the equation that we're plugging into was from the last slide. So it'd be n factorial over n minus r factorial, r factorial. So the n is a 12, so that would be 12 factorial over, this would be 12 minus 5 factorial, and then 5 factorial. Well, 12 factorial would be 12, 11, 10, 9, 8, 7. 12 minus 5 is 7, so that would be 7 factorial, and then 5, 4, 3, 2, 1. So 7 factorials would cancel. You could do 4 times 3, which is 12, and then 5 times 2, which is 10. So you are just left with 11 times 9 times 8. And that would give you 792. Would be your result. So again, n is your total number of items, r is the number you're taking at a time. Now this is another way they're going to ask you, it's another word problem. It says there are 7 points located on a circle as shown. How many different triangles can be drawn using these points as vertices? So I don't have the circle there, but it's a circle with 7 points on it. So there's a total of 7 points. But in order to make a triangle, you would need how many vertices? You would need 3. So it's 7 chosen 3 at a time. So using this formula from before, I'm going to do 7 factorial over 7 minus 3 factorial, 3 factorial. So 7, 6, 5, and then 4 factorial. 7 minus 3 is 4. And then 3, 2, 1. So the 4 factorial would cancel. 3 times 2 is 6. You are just left with 35. So that means that there's 35 triangles you can create out of those 7 points on the circle. Now what I want you to do is I want you to pause this video and I want you to attempt numbers 1 through 15 with me. I want you to attempt them first. If you get it right, then you can skip right over the problem as I do it. If you get it wrong, you can play the video for that problem. You can go problem by problem, so you can just pause after each one, or you can just do it all at once. It doesn't matter to me, but I would like you to attempt them first. Number 1, Amber called Tulsa on the telephone. The cost for the call was $4.40 for the first 3 minutes and $1.10 for each additional minute. Amber talked longer than 3 minutes. In fact, she talked N minutes. What was the cost of her phone call? Well, for number 1, the $4.40 would account for 3 minutes. Plus $1.10 for each additional. So what I'm going to say is that she talked for M minutes, but I need to take away 3 minutes from that. That would be the additional minutes. So if we had M minutes and then we subtract the 3 minutes that are already there, this is going to be what's left to pay for, which means that the $4.40 covers the first 3 minutes plus $1.10 times the minutes that were left, which would be M minus 3. Now, this is a concept review problem, so if you didn't get this one, that's fine because you're never going to be tested over this one. So it'd be plus 110M, and then 1.1 times 3 would be negative 3.3. So if I combine them, the 4.4 minus 3.3, you really get an answer of $1.10 plus $1.10 per minute. And that would be your answer. So it's 1.1 plus 1.1 M. Okay, so moving on, we're going to look at number 2. So there are P pupils in the junior class and they decided to spend D dollars on a school project to which all would contribute equally. Then 20 students refused to donate. How much more did each of the rest of the students have to donate? Okay, so this is another concept review problem. They like to do these now. So we're first going to find out how much each pupil was supposed to pay. So it would be D dollars divided by P pupils. This would be the amount each has to pay. But then 20 students refused to pay. So then I have to, they were supposed to pay D over P, but now 20 students refused to pay. So that would be 20D over P. This is what would be left to pay. But then we have to divide that among how many students are left. So I have the 20D over P, that's the amount that's left, divided by the number of students that's left, which would be P minus 20. So you just multiply top and bottom by the reciprocal. So your result would be 20D over P times P minus 20. That's how much more each of the pupils are going to pay because those students refuse to pay. Okay, so that's for number 2 on that lesson. You can distribute that P if you wanted to too. Now moving on to number 3, which is not a concept review problem, but number 3 says if P varies directly as M squared and inversely as the square root of N. Okay, so I'm just going to deal with that first. So P varies directly as M squared and inversely as the square root of N. So this is my original equation. What happens to P if M is multiplied by 4? So that would be 4M squared, and N is multiplied by 9. So that would be the square root of 9M n. Now that would be 16 m squared over 3 square root n. So what about this equation is different than the original equation? Well, you should see that this side, the equation is being multiplied by 16 over 3. So if I multiply the right side by 16 over 3, I have to also multiply the left by 16 over 3. So what happens to p? It needs to be multiplied by 16 over 3. And that's it for number 3. So you write out the original equation and then you alter it and then just see whatever you ended up doing to the right on the simplified version, you'd have to end up doing to the left, and that just becomes your answer. So for number 4, the big car was only averaging 7 miles per gallon of gasoline. So Bo Willie overhauled the carburetor. Now he uses only 1/3 as much gasoline per mile. How many more miles can he go on 1 gallon of gasoline? So for number 4, he normally can go 7 miles on 1 gallon. But now he can go 7 miles on 1/3 of a gallon, which means he can go 21 miles on 1 gallon. So what is the difference between the 21 miles and the 7 miles? That would be 14 miles. Now moving on to number 5. So this problem is a new problem from this lesson. It says if 8 points are spaced evenly on a circle, how many different triangles can be drawn using these points as vertices? So for number 5, we have 8 points that we're choosing from, and we're choosing them 3 at a time because, again, a circle is made up of 3 vertices. And that equation is 8 factorial over 8 minus 3 factorial, 3 factorial. So 8, 7, 6, 5. 8 minus 3 is 5 factorial. Then 3, 2, 1. So the 5 factorials cancel, and 3 times 2 is 6, which means you are just left with 8 times 7, which gives you 56 would be your result. So those are your new problems. Now looking at number 6, we have how many ways can a committee of 4 people be selected from a group of 8 students? So for number 6, we have 8 students being chosen 4 at a time. There's no order. And that's 8 factorial over 8 minus 4 factorial, 4 factorial. So 8, 7, 6, 5, 4. 8 minus 4 is 4. And then 4, 3, 2, 1. So the 4 factorials cancel. 4 times 2 is 8. So really what I have is 7 times 6 times 5 divided by 3 gives us 70. There's 70 different ways that they can be arranged in a committee of 4 at a time. Now looking at number 7, this is going to be from your last lesson that you learned. Use Cramer's rule to solve. So we need to solve for x, and then we need to solve for y. So I'm going to start with making my 2 matrices on top and bottom. And then that will be x. And then this is going to be y. Now remember, I basically make an x and a y column. In the denominator is where my coefficients are going to go. So the coefficient x is 3 and 2. And then -4 and 3. And both of them are the same. But when I'm solving for x, the x column turns into the equals. So that would be -3 and -4. But my y column stays the same at -4 and 3. If I'm solving for y, my x column stays the same at 3 and 2, but my y column changes into what the equations are equal to, so -3 and -4. Now we're going to evaluate. So I'm going to do top left times bottom right, so -3 times 3 minus -4 times -4 over 3 times 3 minus -4 times 2. So that's going to give me -9 minus 16 over 9 plus 8. So that would be -25 over 17. So x is going to be equal to -25 over 17. Then y, I have to do top left times bottom right. So 3 times -4 minus top right times bottom left. So -3 times 2. And that's all going to be over 17 as well, because they have the same denominator. And that would be, so -12 plus 6 over 17 gives me -6 over 17. So x would be -25 over 17 and y is -6 over 17. Now looking at number 8, this is another one of our new problems. So we have 10-sided regular polygon inscribed in a circle whose radius is 10 centimeters. Find the area of the polygon. So I can't draw a 10-sided regular polygon, but basically for 8, I'm going to draw one of the triangles that's going to be contained inside of the polygon. Basically there's 10 of these. I'm going to split this into a right triangle. When it says that there's a circle the polygon is inscribed in a circle, that essentially means that there's a circle going around like this on the outside, and the radius from the center to the side is 10, so this would be 10. Now in order to find the area of the polygon, I need to know the height and I need to know the base of the triangle. So I'm just going to redraw a right triangle. So 10, this is our base, this is my height. To find my angle, I'm going to take 360 and I'm going to divide it by 20, because if it's a 10-sided polygon, that means there's going to be 20 right triangles. So 360 divided by 20 is going to give me 18. So that means this degree up here is going to be 18. Now to solve for the height, I'm going to use cosine, because cosine is adjacent over hypotenuse. So I have cosine of 18 equals h over 10. So h is going to be equal to 10 times 18 cosine equals, which would be 9.51. Now for the base, I'm going to do sine of 18 equals opposite, which is the base, over hypotenuse, which is 10. So the base is going to be equal to 10 times 18 sine equals, which would be 3.09. Now I'm going to find the area. Now the area, I'm going to end up with 20 right triangles. So I'm going to try and find the area of this right triangle and then just multiply it by 20. So I have 20 times 1/2 base, which is 3.09, times height, which is 9.51, So essentially I'm going to do 10 times 3.09 times 9.51 equals 293.86 centimeters squared. So use cosine and sine to solve for the height and for the base, and then I just use the area of a triangle to solve for the area of the polygon. Number 9, we have the length of a side of a, I don't know what that's supposed to be, of a blank side, of an 8-sided regular polygon is 4 centimeters. So this should be 8-sided, is 4 centimeters. What is the area of the polygon? What is the radius of the circle that can be inscribed in the polygon? Hint, recall that the apothem of a regular polygon is the radius of the circle that can be inscribed in. Okay, so for number 9, I can attempt to draw an 8-sided polygon. So 1, 2, 3, 4, 5, 6, 7. Okay, so basically what I'm going to do is I'm going to have to find the area of this, which I would split this into 8 triangles. But when you're drawing a circle inscribed in it, the radius would actually just be the height of one of those triangles. So I'm going to draw one of the triangles. It says that the length of the side is 4, so that means this is 4. So when I split it into a right triangle, just one right triangle, the base of my right triangle is going to be 2. I need to know the height though, and I'm going to find the angle by doing 360 divided by 16, because there would be 16 right triangles. And that would be 22.5. So that's the degree. This is the degree right here. So I'm going to use tangent, because opposite over adjacent. So tangent of 22.5 equals opposite over hypotenuse, or opposite over adjacent, sorry. So that means h is going to be equal to 2 divided by tangent of 22.5. So 2 divided by 22.5 tangent equals, the height is going to be equal to 4.83. And that I told you was equal to the radius of the circle. So radius is 4.83. And then I also need to solve for what the area of the triangle is. So the area, I have 16 right triangles that make up the 8-sided regular polygon, and it's going to be 1/2 base, which is 2, times height, which is 4.83. So I really just have this times 16, the height times 16, which would give me 77.25 centimeters squared. And that is your area on number 9. Now looking at number 10, so this is one of those old problems. It says 2 8-sided polygons are similar. A side of the larger polygon is 2.5 times as long as the corresponding side of the smaller polygon. What is the ratio of the area of the larger to the area of the smaller? So for number 10, the area of the larger to the area smaller is equal to the side ratio squared. So the side ratio would be 2 1/2, so 5/2 to 1 squared. which would simplify to 25 over 4. And that's all you have to do. So it's a side ratio squared. That's, I think I remember from like a very long time ago. Anyways, so for number 11, we are going to be solving for the unknown parts of this triangle right here. And remember that the side opposite the angle, they constitute a pair, but I'm going to start on number 10 by solving for angle A, because that would be 180 minus 70 minus 60. Which would give me A is equal to 50. Now I can set up my pairs. So I'm going to do A over the sine of 50 equals 10 over the sine of 60 equals B over the sine of 70. So I'm going to start by cross multiplying my first two, which would be A times sine of 60 equals 10 times sine of 50, and divide it by the sine of 60. So that would be 10 times 50 sine equals, divided by 60 sine equals, and you get 8.85. So A is 8.85. Then for B, I have to cross multiply the last two, which would be B times sine of 60 equals 10 times sine of 70. Then you're going to divide both sides by sine of 60. So that would be 10 times 70 sine equals, divided by 60 sine equals, and you should get B is equal to 10.85. That's going to be called the law of sines. So that's the law of sines is where we get number 11 from. Now moving on to number 12. In order for us to graph this, though, we have to make this into standard form. So that means it's going to be x squared over a squared plus y squared over b squared is equal to 1. So I'm going to divide everything by 40 on number 12. So 5x squared over 40 plus 8y squared over 40 equals 40 over 40. And that would simplify to x squared over 8 plus y squared over 5 equals 1. Now this one's tricky because we have to graph this by taking the square root of the denominators, and neither of those come out evenly. So I'm just going to approximate. So the square root of 8 is approximately 2.8. So it's going to be almost to 3 in both directions. And then the square root of 5 is about 2.2, so just over 2. And that is going to be your ellipse. So that's just an approximation. So the length here should be about square root of 8. Oops. The length here should be the square root of 5. Now looking at number 13, I gotta multiply top left times bottom right minus top right times bottom left. So for number 13, I have 3 times k minus k times k plus 1 minus 1 equals 0, because I'm going to set it equal to 0. So I have 3k minus k squared minus k minus 1 equals 0. So I have negative k squared plus 2k minus 1 equals 0. If I divide this all by negative 1, then I get positive k squared minus 2k plus 1 equals 0. That factors evenly, which is perfect. So that would be k minus 1 squared equals 0, which means that my result is k is equal to 1. Anytime it factors out evenly, it's a lot easier for us because then we don't actually have to do quadratic formula. Now looking at number 14, I find the coordinates of the focus and the vertex and the equation of the directrix for the parabola y equals negative 1 over 16x squared. So for number 14, I know that the equation of the parabola is y is equal to 1 over 4p times x minus h squared plus k. Well, the h and the k are actually going to be the coordinates of my vertex. Notice that on the equation that they give us, there's actually no h or k, which means that my vertex is going to be at 0, 0. Now, the p is going to be equal to the distance from the vertex to the focus. So if I set 1 over 4p equal to negative 1 over 16, that means I have 4p equals 16, which means p is equal to negative 4. So from the vertex, the focus is going to go down 4. So that means the coordinate will be 0, negative 4. Now, if I draw this out, 0, 0 is my vertex. My focus is down 1, 2, 3, 4. It's my focus, which means my parabola is going to be about here. Then my directrix is going to be in the opposite direction. So 1, 2, 3, 4. And this is going to go through the y-axis. So my equation of my directrix is going to be y is equal to positive 4. And that is your result. So these are your results, and then including the diagram for number 14. Now, lastly, for number 15, we are going to sketch this function. But what I'm going to do is I'm just going to focus on the log 2, and then I'm going to add 1. It's basically going to shift on the y-axis 1, up 1. So if I graph x equals 2 to the y, negative 1, 0, and 1. 2 to the negative 1 is 1/2. 2 to the 0 is 1. 2 to the 1 is 2. So if I graph this, I'm going to go over 1/2 down 1, over 1 up 0, and then over 2 up 1. But see, this is just going to be my original. But then I need to shift everything up 1. So that means instead of here, this is going to go here. Instead of here, this is going to go here. Instead of here, it's going to go here. So my actual diagram will look like this. And that concludes numbers 1 through 15 on lesson 75. Hope that got you started, and I hope you did attempt those before doing them with me, and I hope you have a great day. Bye.